Hello friends, I will and my dear students, I welcome you all to my channel. I hope you are all doing well and your studies are also going on well. This is part 5 video on the chapter of squares and square roots, where I will discuss about square root of a perfect square, how to find the square root of a perfect square using the long division method directly by solving the problems of exercise 3E. So there will be no theoretical discussion on this topic. I will directly solve the problems of exercise 3E that will clarify all the concept of finding square root of a perfect square using long division method and the application of long division method to solve some typical problems. So by solving the exercise 3E, we will understand the concept. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly, or if you have visited my channel for the first time, seeing my video for the first time, I strongly suggest and request that you support me by subscribing to my channel, and please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I do not have notes for this video. So in this video, we will understand how do we find the square root of a perfect square number using the long division method. And this the method of long division is specifically useful for finding the square root of a perfect square, which is a relatively large number, just like 66049 or 6348, like 4 digits or 5 digits or even 6 digits. So I have my the exercise 3E, the problems on the left hand side. I hope it is visible. Let me quickly check whether everything is visible or not. Okay, I hope you can read the questions from the exercise 3E. Okay, so let's try to solve. I will not discuss the steps, or in computer language it is called algorithms, of how a long division method works. Let's solve the problems and understand it. Okay, so let's solve the problem number 1 with a very small number. So we have to find square root of 5, 7, 6. Okay, so fundamental. So what are the steps? You have the number, the given number is 576. 576. 576. You create pairs of digits of this number. From this number, you create pairs of digits taking from the right hand side. So the first pair of digits from the right hand side is 76, and whatever digit is left over, you also mark it. So mark each pair of digits from the right hand side with a bar on top of the 2 digits, and if any digit is left over, you also put a bar on the top of the digit. So these pair of digits or the leftover single digit are called periods of the given number. Now we will I will start from the leftmost period, which is 5 in this case, which is a single digit. In other numbers, for other numbers, it could be a pair of digits, but for this number, it is a single digit. It is the leftmost period. Okay, what do we do now? You find the number, or find the digit rather. Find the digit. I have to find a digit and put here. I have to find a digit and put here, so that I am writing a little bit of theoretical part. Find A such that A multiplied by A will be less than or equal to the leftmost period. The current we will always start from the leftmost period, which is 5 in this case. So it has to be less than or equals to 5. Okay, so you find the digit A, which when multiplied by itself should be less than or equal to the leftmost period, which and it will always start with the The leftmost period, which in this case is 5. So what will be 5? What will be A? A will be definitely, it cannot be 3 because 3 into 3 is 9. It will be 2 because 2 into 2 is 4, which is less than equal to 5. So you have this A must be the maximum. The maximum digit, the largest digit A, such that A multiplied by A is less than equals to will be 5. Okay, so in this case it will be, this implies that A equals to 2. So we just need to divide the number of, what we will do then on the we will put a since we need, so we will multiply 2 with 2, and so since we have multiplied 2 with itself, that 2 will go in the quotient, and whatever A into A is, which is 4, will come here, and we will take the remainder from the current period, and the current period is 5. So 5 minus 4 is 1. 5 minus 4 is 1, and we will bring down the next period. The next period is 76. We will bring down the next period, that is 76. Now the dividend, initially the dividend was the given number, that was 576, and we had to find the divisor, that will be a single digit, which when multiplied by itself will give a number which is less than equal to the first, the period, that is the leftmost period, which is 5. So the divisor was 2, and the dividend and the quotient was also 2. The quotient was also 2. Okay, and so then 2 multiplied by 2 is 4, and we subtracted 4 from the period, so it is the remainder was 1. And then we, if there are any more periods left, we will bring down the next period, that is, so we brought a 76 down, and the remainder is, now the new dividend is 176. Now the new dividend is 176. Now what will be the divisor? The divisor will be whatever the current quotient is, which is 2 in this case. The current quotient is 2. We have to multiply the quotient with 2. We will multiply 2 multiplied by 2. The quotient was 2. Whatever the current quotient is, we will multiply it by 2. So 2 into 2 is 4. So now the dividend is 176. The divisor is 4. Now we will have to find again a digit A, such that, find, in this step we have to find A such that the A will be, the digit A will go to the right hand side of the digit 4, which is the current divisor. So we will find A, and we will make the divisor 4A such that what will be A, such that 4A multiplied by A will be less than equal to the current dividend, that is 176. Find A, the largest A, such that 4A multiplied by A is less than equal to 176. What can this A be? What can this A be? This you have to figure it out, doing some oral or mental calculation. Now, what can be? Now, if 4 is, so you have to consider the dividends first 2 digits. The leftmost 2 digits is 17. So possibly 4 will 4 work if I consider A as 4. So 44 into 4 is 176. This so A will be 4 as 44 multiplied by 4. This was the A, is equal to 176. So now find A such that okay, now I am, so what happened now? So after this step, when we found A equals to 4, what is happening? 176 and over here we have to be 4, and the question, this 4, this A, the 4A, the A that we have found will go also in the question, that is 4. And we got 44 into 4 is 176. 44 into 4 is 176, and the remainder is 0, and there are no more periods left. So the answer is 24. That is, therefore, the square root of 576 is the final question, that is 24. Now I might be doing some mistake in doing the long division method, so it's better I will quickly check in a calculator indeed whether 24 into 24 is 576 or not, and it is 576. So what we did, okay. So if you think that my notes that my calculation writings will help you, you can take a screenshot while I am solving a problem. And also when I am speaking, if you think if you need to note down anything, always take notes, because taking notes from any source of content is always a wise thing to do. If you think you are learning something new, or you have learned some concepts, always note it down. Okay, so I hope you understood the process of long division method for this number. Now the more you find the square root of more numbers, it will be more clear. Okay, let's try to do the second one. Possibly I will find all the square roots, so that it will give you enough information of how to find the long division, not find, how to actually how actually the long division method works. So this video might go a little long, because after the square roots we have to solve few word problems. So let's see. Okay, so this is we have to find the square root of 1,444. Okay, so the number is 1,444, and once I create the pairs from the right hand side, the pairs are 44 and 14. Okay, so now I will divide. This is my current dividend. I will have to figure out the divisor. I will have to figure out the divisor over here. It will be a single digit, because we are now only dealing with the first period. We are now only dealing with the leftmost period. So the A will be such that find A such that A multiplied by A is less than equal, the largest A, find the, I should write, find largest A, which will such that A multiplied by A will be less than equals to 14. Now this implies, what can A be? Can A be 3? Yes, A can be 3. Can A be 4? A cannot be 4, because 4 into 4 is 16, which is greater than 14. So A can be 3. And definitely A is a, in the first step, A will be a single digit. So A is 3. Okay. Now, so I'm how will I write? Okay. So we divided the first divisor, we figured it out to be 3, and the quotient was also 3, because this A has to be multiplied by A itself, so that it is less than equal to the first period, that is 14. So over the quotient, in the quotient it will also be 3, and we got 3 multiplied by 3 is 9, and we'll take subtract 9 from the leftmost period. This is 5, and then we will bring back the next period in the remainder. We will append the next period with the remainder, which is 44. Okay, fine. Now we have to okay, what is the next step? The next step, the dividend becomes the remainder, the previous remainder. Actually 44, the correct way of doing is Okay, so now because okay, so we brought down the next period, which is 44, and appended with the remainder, which was 5. So it becomes, the new dividend becomes 544. Now I have to see, I have to divide 544, and what will be the divisor? The divisor will be the current quotient is 3, so I will multiply. I will multiply 2 with the current quotient, and it becomes 6. And it becomes 6. Now I have to find the digit a over here, such that find a find a such that 6a multiplied by a, largest a, sorry, I'm always forgetting that. Find the largest a such that 6a multiplied by a is less than 544, is less than 544. What could a then be? You have to see, this thing you have to mentally work it out. Now, can it be 9? It cannot be 9. Can it be, if I take 9, then a as 9, then 69 into 9 is exceeding 544. Can it be 8? 8. 8, what is, can it be 8? So 68 into 8 is 8, and 48. Okay, so it exactly running. So this implies a equals to 8. This implies a equals to 8. So we are having v 544, the a will be 68, and this 8a will get appended to the quotient, that is 38, and when we multiply 68 with 8, it is 544, and we subtract, and it is 0, remainder is 0, and there are no more period left. So the answer is 38. So therefore a square root of 1444 is equal to 38. I will always check with the calculator whether the answer, okay, fine, 38 is a correct square root. Okay, so as I will solve more problems, you will hopefully you will get the idea of how long division is working, how we are bringing down the next period, and then how we are figuring out what will be the current divisor, and then how we are generating the quotient, how the quotient is getting modified, updated this way. Okay, let's do problem number 3. Problem number 3 is square root of 4, 4, 8, 9. Now I think okay, let me do this one, then I will do next pick up a 5-digit number. Okay, so we have 4, 4, 8, 9. This is the given number, which is actually a perfect square. So we create the pairs of digits, that is the periods, from the right hand side, and we have these two periods. And now we will divide this. This is we will divide the leftmost period. 44 will be the current dividend. So I have to find the digit. I have to find the a over here, the divisor a, such that find the largest a. Find largest a such that a multiplied by a will be less than equals to 44. Now this implies what will be a? If a will be how much? A will be 7. A 7 7 49. No, 6. 6 6 36. So a will be 6. So the divisor, initially the starting divisor will be 6, and so the quotient will also be 6. 6 multiplied by 6 is 36. and we will subtract 36 from the leftmost period, and it is 8. It is 8. Okay. Now we will bring down the next period. We will bring down the next period 89. So the remainder becomes 889, but this will be the next dividend. This will be the next dividend. So we have to now next dividend is 889, and the divisor will be, we have to multiply the current question by 2, and we get 12. 6 multiplied, the current question was 6, we multiplied it by 2, and we got the divisor as 12, the partial divisor as 12. Now we have to find a such that we got 6 into 2 as 12. We have to find, let's say I am taking some another letter, because my A sometimes looks like 9, so it is confusing. So I am taking X. So find X, find largest X, find largest, and always this A and X are digit. Find largest digit X such that 12x multiplied by x is less than equal to, the current dividend is 889. So this implies what will be x. So this thing could be a little bit of challenging to find the x. Now so 888 is a 3-digit number, 12x. Now if you take x as 7, if you take x as 7, what will it become? So 127 multiplied by 7, this is 49, and this is 14, 18 and 8. Oh, perfect. So this implies x will be equals to 7. Okay. So now what we got, the x will be 7, and this x will also get appended with the question. So we have 127, and we were dividing 889, and 127, the 7 will also go in the question, and we have 127 multiplied by 7 is 889, and this will be 889, not 888. Okay, and the remainder is 0, and there are no more periods left. So the square root answer is 67. So we have 4489 equals 67. Okay. I will quickly check whether this is correct or wrong. 67 multiplied by 67 is 5933. What? 67 multiplied by 67 is 4489. Okay. Now let's do what is number 4? 6241. Now I will take a 5-digit number, that is problem number 7. Problem number 7 is a 5-digit number. So 11449. Okay. So the given numbers are the given number is perfect square, that is 11449. We will create pairs of 2 digits, periods of 2 digits, that is a period is a pair of 2 digits from the right hand side. So first pair, second pair, and the last pair, leftmost pair, which is a single digit. Now we will consider the leftmost period, which is 1. So definitely over here it will be 1, and the question becomes 1 multiplied by 1 is 1. So when 1 is subtracted from the leftmost period, which is 1, this is 0. And there are more periods. I will bring down the left. I will bring down the next period, that is 14, and bring down 14. Okay. Now what will I do? So 014, that is 14, is the new dividend, and these two and the new divisor will be the current quotient is 1 multiplied by 2. So current quotient is 1, 1 multiplied by 2 is 2. 2. So now I have to find find the divisor digit x such that, so find largest digit x such that 2x multiplied by x is less than equal to 14, because the remainder 014, which is 14, is now the current dividend. So what can x be such that 2x multiplied by x is, what can largest x be such that 2x multiplied by x is less than equals to 14? It cannot be 1. It cannot even be 1, because 21 by multiplied by 1 is 21. So it has to be 0. It has to be 0. It has to be 0. So we got over here we were dividing 0, 1, 4, and over we have 20, and since this x will also get appended to the question 10, and so if we divide, so x is 0, so we have to, when we multiply 20 with 0, it's 0, so we have 0, and when we subtract 0, 1, 4, 0 from 0, 1, 4, it is again 1, 4. It is again 1, 4, and then I will bring the next period over here, which is 49. And what will be the dividend? The partial divisor. The current question is 10. The current question is 10. 10 multiplied by 2 is 20. So 10 multiplied, so we have 20, because the current question is 10. So we will multiply question with 2, and we have 20. Now we have to again find x over here, so that I will copy paste this thing, duplicate. Now we have to find a largest x such that 20x, such that 20x, one second, my handwriting is so bad. Okay, such that 20x multiplied by x has to be less than equal to 1449. So what can x be such that largest x digit, x will be a digit such that 20x multiplied by x will be less than equals to 1449. Now can it be 7? Yeah, you can see that 7, if I consider x as 7, so 207 multiplied by 207 is 207 multiplied by 7 is 49, 4 and 14. So over here the x will be 7. So what we are getting in this, now we will have the dividend is 1449, and over here we got 207, and the 7 also got appended with the current question, that is 107. And so we will get, when 207 is multiplied with 7, we are getting 1449, remainder is 0, and there are no more periods. Therefore square root of 11449 is the question which is 107, which is 107. So 107 multiplied by 107 is 11449. Okay. Now okay, so I hope you are taking screenshot while I am solving it. Okay, let's do again. Let's also do the problem number 8. So you have to solve a lot of problems to really get a good hold of the concept of long division method to find the square root of a perfect square. So we have to find the square root of 14161. Okay, 14161. Okay, so if we create we have the number 14161. We create the periods 61, 41, and 1. So the leftmost period will be the dividend, and we have to see which is 1. So obviously the divisor will be 1, because 1 into 1 is equal to 1, and the remainder becomes 0. And then we will bring the next period, which is 41. Now I will not write detailed steps. Okay, let me do it. So 41. Now, so the remainder 041 will be the next dividend, and what will be the partial? What will be the partial divisor? That will be the current quotient. Current quotient multiplied by 2. So current quotient is 1 multiplied by 2. That is 2. Now I have to think of a digit over here x such that. Let me see. No, can I do test? No. What is happening? Okay. So I have to find now in this step, find largest digit x such that 2x multiplied by x is less than equal to 41, because the dividend is 41. So what can x be such that 2x multiplied by x less than equals to, remember this 2x is not actually 2 multiplied by x. This 2x is a 2-digit number, where the leftmost digit is 2 and the rightmost digit is x. Okay. So if I put x cannot be 2, because 22 into 2 is 44, so it has to be 1. Has to be 1. So now we have, after substituting x as 1, we get 21. Okay, and the dividend was 041, or you can also write 41. And this one will also go, the x1 will also go to the appended to the current question. The current question was 1, and after, when x is appended, which is 1 to 1, is 1, 1. And when 21 is multiplied by 1, that number is 21. We have to subtract from the current dividend, which is 0 and 2. So the remainder is 20. Now we have to bring down the next period, that is 61. And now we have to, what will be the partial divisor? The next partial divisor will be 11. We have the current question as 11 multiplied by 2, that is 22. And now we have to find a digit x over here such that, again, we will have I'm trying to duplicate this. Find digit x such that we need to have such that 22x, that is this 3-digit number 22x, and x is a digit, such that 22x multiplied by that digit x should be less than equals to 2061. Now what can x be? Can it be 4? Yeah, it can be 4. Can it be okay? So the 2061 is a 4-digit number, and 22x is a 3-digit number. We can take something like 8. Will 8 work? 9. Let's check out 9, because the 2061, the last unit digit is 1, and we know that we have learned from the previous videos from the find the squares of the properties of squares, that if the square number, if a perfect square or a square number ends with 1, then possibly the number whose the square root will will end with 9. So you can think of 9. So 2 to 9, let's see, multiplied by 9, 81, 26. Yes, it is perfectly 2061. So this implies x equals to 9. So we have, when we substitute x as 9, what is happening? This thing is not moving anymore. What is wrong? What is wrong happening? Why this is not scrolling? One second, friend. I'm having some technical problem with the software where I'm writing. It's not scrolling up and down. What is wrong? Okay. So now when we substitute, we have found that x is equals to x is, and the last step x will be 9. So we will have 2 to 9, and the dividend was 2061, and this 9 will also get appended to the question, and it will be, the question will become 119. And so when 2 to 9 is multiplied by 9, when 2 to, so we have here 2061. So when 2 to 9, when multiplied by 9, we are getting 2061, and so the remainder is becoming 0, and there are no more periods left. So the answer is 119. The square root of, therefore, the square root of 14161 is equal to 119. So let me quickly check if I did it correctly or not. It is 14. Okay, it is fine. It is 119. Okay, you can take a screenshot. I hope you are understanding the process of long division method, how we are finding the square root of a perfect square. Okay, let's do 9 is also 5-digit number. Let's do a 6-digit number. Let's try 6-digit number. Okay, all the rest all the numbers are 5-digit number. But anyway, let's try the problem number 10, which is we have to find the square root of 179556. Okay, so the number is 17956. We create periods of 2 digits from the right hand side, and the periods are 56, 79, and 1. Okay, so we will divide, the current dividend is 1, that is the leftmost period, that is 1. So obviously the divisor will be 1 and the question will be 1. 1 multiplied by 1 is 1, and we will subtract 1 from the leftmost period. This becomes 0, and we will bring down the next period, that is 79. So the next dividend becomes 079, and the partial divisor will be, we will have to bring, we have to multiply the current quotient, which is 1, and the partial divisor becomes 2. Now we have to think a digit over here, x, such that find largest digit x such that the number 2x, please always remember that x is not twice x, it is a number. 2x is a number, 2-digit number, where the leftmost, where the digit at the tens place is 2 and the digit at the units place is x. so that 2x multiplied by x is less than equal to the current dividend, which is 79. What can x be? Can x be 3? Can x be 3? Can x be 4? X cannot be 4, x can be 3, because 23 multiplied by 3 is 69. X cannot be 4. So this implies x equals to 3. Okay. So in the next step, what we are getting, we are having x as 3 and the dividend was 0.79, and this 3 will also get appended to the current question. Current question is 1. 3 will get appended, so it becomes 13. And so 23 multiplied by 3 is 69. The 69, we will subtract 69 from the current dividend, which is 79, and the result of subtraction will be 10. What do we do next? We bring down the next period. We bring down the next period. So we have the next period is 56. The current dividend now becomes 1056. The current dividend will become 1056, and now we have to what will be the partial divisor? Next partial divisor, the current quotient, which is 13 multiplied by 2. So 26. 26 will be the partial divisor. How do we get 26? The current question is 13 multiplied by 2. So 26. Now we will have to find again a digit x over here, such that find largest digit x such that 26x, that is the three-digit number 26x multiplied by the digit x is less than equal to 1056. Now obviously the x will be 6, because we know that the square of what will be that digit whose square gives the 6 as the ending as the rightmost digit. It is only there are two digits. It is there are 4 and 6, because 4 into 4 is 16. The rightmost digit is in 16 is 6. Also 6 multiplied by 6 is 36. So also 36, the rightmost digit is 6. In the number so we have to find x such that 26x multiplied by x will be less than equals to 1056, and in 1056 we have the ending digit is rightmost digit is 6. So x has to be either 4 or 6. So if you have 4, it cannot be 6, because it will then, if it is 6, then 266 multiplied by 6 will exceed 1056. It has to be 4. So let's see, if you take 264 multiplied by 4 is 16, 25 and 10, and it is perfectly 1056. So x is, this implies x is 4. So what happened? So this x will become 4 and 1056, and this 4 will also get appended to the current question. So current question will become 134, and we know that 264 multiplied by 4 is 1056. The remainder is 0, and there are no more periods left. So the answer is 134. That is the current question. The final question is the square root of the given number. So therefore, square root of 19600. Are we doing 19600? No, 17956. Okay. Square root of 17956 is equal to 134. 134. I will quickly check whether this is correct or not. 134 multiplied by 134 is 17956. Okay, fine. Now I will do the last one, that is 9416. The last one, problem number 12. we have to find 9 to 4, the square root of 9 to 4, 16. So the number is 9, 2, 4, 1, 6. We create the periods, that is pair of two digits from the right hand side. So we have the period 16, 24 and 9. 9 is the leftmost period. So definitely the first divisor, the first dividend is the leftmost period, which is 9. The first divisor definitely will be 3, because we know 3 into 3 is 9. And the quotient becomes 3. So 3 into 3 is 9. We subtract and we get remainder 0. And then we bring down the next period, which is 24. And now the dividend becomes 0 to 4. And the partial divisor will be 3 into 2, 3 into 2, which is 6. Which is 6. Now we have to find the digit x over here, such that find largest digit x such that 6x, that is the two-digit number, where the digit in at the tens place is 6 and the digit at the units place is x. This multiplied by the digit x itself should be less than equals to 24. And definitely we can see that x has to be 0. If x cannot be 1, if x is 1, 61 multiplied by 1 is 61. It is crossing 24. So this implies x is definitely 0. So we have x is 0 and the dividend was 0 to 4, that is 24. This 0 will get appended to the current quotient. So the current quotient will become 30 and 60 multiplied by 0 is 0. So the remainder still becomes to 24, and we bring down the next period, that is 16. So the current dividend becomes 2416. And what will be the partial divisor? Whatever the current quotient is multiplied by 2, that is 60. Now again we have to find x, a digit over here, such that find x. Now I am writing in short, I will not write everything. So find x such that 60x, that is the three-digit number 60x, multiplied by the digit itself is less than equal to 2416. What can x be? Again, the x can obviously be, since the 2416 it is ending with the digit 6, so the x can only be 4 or 6. So you can clearly see x cannot be 6, x will be 4. So 604 multiplied by 4, it is 16, 1, 2, 4, 1, 6. So this implies x equals to 4. So what do we got? What do we get? So we get 604 and the dividend was 2416, and this 4 will get appended to the current quotient, and a current quotient will be 304, and when 64 multiplied by 4, it is 2416. 2416, and we subtract 2416 from the current dividend, and it is 0, and there are no more periods left. So definitely the final quotient is 304, that is the square root. So therefore square root of 92416 is equal to 304, is equal to 304. Okay. Give me 2 seconds, friend. I will have some water. My throat is choked. Okay. Okay. So I hope now by now you have understood how the long division method is working, how it works to find the square root of a perfect square which is relatively a larger, like it could be 4 digits, 5 digits, or even 6 digits. Now let's do the word problems. Now the word problems, there are some typical word problems which you should be understand very well and familiar with. So problem number 13. It is saying find the least number which must be subtracted from 2509 to make it a perfect square. Now always remember then that when you are performing long division method, when you are performing the long division method, it can be the case that you will have some remainder left and there are no more periods. So some remainder will be remaining. If any remainder remains and there are no periods, that means that the number is not a perfect square. Then what from the remainder, based on the remainder, you can wisely say whether what could be the list of what number can be added to the given number so that it will become a perfect square, or what number can be subtracted from the given number to make it a perfect square. So like that. So that is the basic concept. After doing long division method, whatever the remainder is, from that remainder you will have to solve the problem, take the decision. Okay, so it is saying find the least number which must be subtracted from 2509 to make it a perfect square. Okay, so the first thing is that we have to do the long division method of 2509, which is the given number. Okay, so let's do the long division method. 2509, I will create the periods 09 and 25. So the leftmost period is 25. Clearly the divisor will be 5. 5 question will be 5 multiplied by 5 is 25. I will subtract from the leftmost period, it becomes 0. Okay, now I will bring down the next period. That is 09. So the current dividend becomes 009, which is practically 9, and you see that okay, now if you now the partial divisor will be, if you follow the long division method, the partial divisor will be 5 multiplied by 2, which is 10. Now obviously, so now we have to find the digit x. Find x such that we have to find x such that 10x, that is the 3-digit number 10 and x multiplied, the digit x has to be less than equal to 9. Now obviously x has to be 0. If x is 1, the result will become 101 multiplied by 1 is 101, which is way too much more greater than 9. So x has to be 0. This implies x has to be 0. So what is happening now? We have 100, 0, and it was 009. Since the x is 0, it will get appended to the current question. It will have 50, and 100 multiplied by 0 is 0, and the remainder is 9, and we do not have any period left. So the final quotient is 50. And we are getting a remainder of 9. So we can clearly see that 2509 is not a perfect square. Now it is asking find the least number which must be subtracted. Now we can clearly see that from this long division method, it implies, we can say that we can clearly say that 50, whatever the final question is, 50 multiplied by 50, if we do that, this is equal to we can see 2500, and also see that the remainder is 9. If we subtract the remainder from the given number was 2509. If we subtract the remainder, we are getting 2500. So 2500 2500 is a number which is a perfect square, because we can see that 50 multiplied by 50 is 2500. So it has asked to find the least number which must be subtracted, a number that must be subtracted from 2509, so that it will become a perfect square. And we can clearly see that if we can subtract 9 from 2509, the result 2500 will be a perfect square. But is the number 9, which is the remainder in this case, is that the least number? The problem has asked to find the least number which we must subtract from 2509, and the answer is of course yes. The whatever the remainder is in a long division method, if you have a remainder, that will be the least number that must be subtracted from the given number to make it a perfect square. So therefore least number to be subtracted is 9. 9 is, since we are having a remainder of 9, so 9 has to be the least number which when subtracted from the given number will make it a perfect square, and it has also a perfect square. Okay, and after subtracting 9 from the given number, it becomes 2500, which is the square of the current question, that is 50 square. So in a question you might also be asked that what least number must be subtracted from the given number to make it a perfect square, and also find whose square is that number, whose square is that perfect number which is obtained after subtracting the least number from the given number. So in this problem, that is 50. The square of 50 is 2500, and 2500 is the number that we obtain by subtracting 9 from the given number, and 9 is the least number that need to be subtracted from the given number to make it a perfect square. Okay, so this was about what least number that must be subtracted from the given number to make it a perfect square. That will always be the remainder obtained after doing the long division method. Okay, let's then the problem number 14 says, find the least number which must be subtracted from 7581 to obtain a perfect square. Okay, it is same. This problem is same as 13, but additionally it is asking find this perfect square and its square root. That is the perfect square that you obtain after subtracting the least number from the given number. Whatever that perfect square is, you have to find the square root of that number. Okay, so what is the number given? The number given is 7581. We have to first do long division method. So the periods are 81 and 75. So the leftmost period is 75. We have to find at the very first stage, we have to find the digit x. Find x, find largest x, and it will also be a digit, largest digit x, such that x multiplied by x will be less than equals to 75. That is the leftmost period, 75. So this implies x cannot be x. If x is 7, 7 multiplied by 7 is 79, and 6 multiplied by 6 is 36. So this implies x is equal to 6. So we have the divisor was 6, 75, 81. The question will also be 6. 6 multiplied by 6 is 36. When we subtract 36 from the leftmost period, we get 39. We get 39, and we bring down the next. We bring down the next period, that is 81. This so 3981 becomes the new dividend, and the quotient will be 2 multiplied by the current. The next partial divisor will be 2 multiplied by the current quotient. Current quotient is 6, so 6 multiplied by 2 is 12. Okay. Now we have to again find x such that wait a second. I think I did something wrong. 39. When the remainder was 9, 10, 9, 9. I think when the initial remainder, 1 second. So at this stage, we have 6 multiplied by 6 is 36, and when we subtracted 36 from 75, we get 9 and 3, 39 as remainder. But I think before bringing down the next period, we should again with this remainder will be the dividend. This remainder will be the dividend. Why this is so? Because I don't think we should bring down the next period at this stage, because the remainder is 39, and the quotient is 6. So if we the next dividend, I guess, will be 39 itself, the remainder. We should not bring down the next period as of now, and the next partial divisor will be 6 multiplied by 2, that is 12, and definitely this digit has to be 0. Six, 36, 7, 7, 49. Oh, I am doing it very, very wrong. I'm so sorry. So it was 75, so it will not be 6. I'm doing very, very silly mistake. I'm really sorry for that. And my machine is also running very slow. Nothing is working properly. Okay, so this will not be 6. So what will be the largest x such that x is a single digit? Largest x such that x multiplied by x will be less than or equals to 75. It cannot be 9, because 9 into 9 is 81. It can be 8, because 8 multiplied by 8 is 64. So definitely x is 8. So we have 8. The first divisor will be 8, and we have 75, 81. The quotient will also be 8, and we have 64. Subtracting 64 from the leftmost period, 75, and this is 11. This is 11. And now we will bring down the next period, that is 81, and the next partial divisor will be 8 into 16. 16. Now we have to find x again such that find largest digit x such that the 3-digit number 16x multiplied by the digit x is less than or equal to 1181. 1181. So this implies, what can x be? Can x be what can x be? Can x be 4? No, I think x will be 6. X will be 6. So 36, 36, 39, and 996. 996, because x cannot be 7, because because x cannot be 7. 167 multiplied by 7 is 49, and 42, 46, 11. So it is becoming 110. It can be 1169. We have to make select x such that 16x multiplied by x is less than or equals to 1181. And if you select x as 7, 167 multiplied by 7 becomes 1169. 49, 42, 46, yes. So definitely then x will be 7. X will be 7. So we get this is 167, and we have 1181. This 7 will get appended to the current quotient. So we will have 87 as current quotient, and 167 multiplied by 7 is 1169. 1169. We subtract 1169 from the current dividend, that is 1181, and we get 12. We get 12, and there are no more period left. So definitely the final remainder is 12, and the final quotient is 87. So it is asking find the least number. Okay, so definitely this will, therefore this implies 12 is the least number to be subtracted. Therefore, the given number was 7581. 7581 minus 12 is equal to what will be 9 to 6, 7569. 7569, which has to be definitely the square of the current quotient. So for after doing a long division method, whatever remainder you are having, if you subtract the remainder from the given number, it becomes a perfect square. And whose square is that perfect square? That will be the square of the final quotient, that is 87. Let me quickly check whether 87 multiplied by 87 is 7569 or not. Yes, it is. So for this problem, it has two parts. The first part was to find the least number which must be subtracted from 7581 to obtain a perfect square. That is, of course, this number is 12, which must be subtracted. The 12 is the least number that must be subtracted from 7581 to make it a perfect square, and that perfect square is 7569. The second part was find this perfect square and its square root. So definitely it has three questions. The first part was what is the least number that must be subtracted, which is 12, and then so after subtracting the least number, what is the perfect square? That is 7569, and the square root of 7569, which has to be the final question. So 87. Okay. This was question number 14. Okay. So this was all about finding the least number. This question, the pattern of this question is finding the least number that must be subtracted from a given number to make it a perfect square. And then from that, we know that if we subtract the least number from the given number, whatever the number will be, it will be a perfect square, and its square root will be the final quotient in the long division method. Okay. Let's do problem number 15. Problem number 15 says find the least number which must be added in this time. What is the least number which must be added to 6203 to obtain a perfect square? Find this perfect square and its square root. Okay, so the number is 6203. So the first step is always to do the long division method. So the periods are 03 and 62. So what will be the initial divisor? X such that find largest digit x such that x multiplied by x is less than equal to 62. 62 is the leftmost period. So this implies what will be x? X will be definitely 6. No, sorry, x will be 7. 8, it can't be 8 because 8 multiplied by 8 is 64. So x is 7. So we have 7 and then 6, 2, 0, 3. So the question will be 7, and we have 7 multiplied by 7 is 49. We will subtract 49 from the leftmost period, and we have 3, 13 as remainder, and we will bring down the next period 0, 3, and then the next partial divisor will be 7 into 2, that is 14. And now we have to find the x over here such that so now find largest x such that 1 4 the 3-digit number 14x multiplied by the digit x is less than equal to 1303. What can x be? So that 14x multiplied by x is less than equal to 1303. Can x be if you consider x, now this thing you have to be do it very quickly orally. Can it be 9, 81 and 36, 44 and 13, 13441. So it is 1341 is exceeding, so definitely x has to be 8. X has to be 8. So we have 148 and 1303. This 8 will get appended to the current question 78. The current question becomes 78, and 148 multiplied by 8, how much is 148 multiplied by 8 is 64, 32, 38, 11. So we have 1184. After subtraction we get 9, 13, 1, 119. Okay, so we get and there are of course there are no more periods, so the remainder is 119. By the way, so this was a remainder. This was final. This was actually, in this case, it was a remainder. And in this case, the previous problem, the remainder was 12. The remainder. So this is the 119 is the remainder when we do the long division method, and the final question is 78. Okay, so now it is asking what is the least number that must be added. What number that we must add so that it will become a perfect square. So the concept is that the next number, so we know that this implies that 78 whole square is definitely we can see that 78 whole square is definitely less than 6203. Why? Because if you do a long division method and there is a remainder, then obviously the final quotient square is less than the given number. That is why there is a remainder. So we see that 78 whole square will be less than 6203. Now what least number we must add to 6203 to make it a perfect square. So obviously it is clear that the next perfect square number has to be 79 whole square. or you can say that 78 square is less than 6203, and also we know that 6203 will be less than 79 whole square. So the next 6203 is not a perfect square, but what is the perfect square which is the next perfect square which is greater than 6203? It has to be 79 square, 79 whole square. So 79, what is 79 square? You have to quickly find it. 79 square, what is 79 square? Square, okay. Now there was some method, shortcut methods for finding the square of two-digit number. I forgot. There was some shortcut method like using the formula of a plus b whole square. The formula was, now for this problem, you can just multiply 79 with 79, but if you remember the shortcut methods of squaring a number, that will be a wise way of solving it. So anyway, I am doing it 79. Okay, let's see. Let me quickly put my laptop into charge. My laptop was discharging. Okay. So we know that how to square a two-digit number. If you have a two-digit number of the form xy, let's say xy, what happened? Let's say xy is a two-digit number. How do we find its square? So there is a formula 100 x square plus 20xy plus y square. So xy are the digits of the xy, x and y are digits, and xy is a two-digit number. So what will be the square of xy? Xy whole square, it is 100x square plus 20xy plus y square. So if we apply this formula, this is a shortcut formula using the a plus b whole square formula, because we know that the number xy is nothing but 10x plus y, 10x plus y, and if you do whole square of 10x plus y, the result is 100x square plus 20xy plus y square. So now what is x in this problem? We are trying to find the square of 79. So this will be, so therefore okay, so 79 square will be equal to 100 into 7 square, that is 49, plus 20 into 7 into 9, so 20 into 7 into 9 and plus 9 square, that is 81. I don't know whether this will be faster or not. You consider that yourself, which is faster, just by either by multiplying 79 with itself or following any shortcut methods. Now I think for two-digit number you can directly do the products, because the shortcut methods I don't think are really working, will make the calculation faster. So what is 79 square? I will do 79 multiplied by 79 is 81, 63, 71 multiplied by 63 and 49, and 49, 55, so 1, 4, 12, 6, 6241. So this is 6241. This is 6279 whole square is 6241. So therefore the number that must be, therefore the least number to be added to the given number will be equals to the difference of the next the 79 whole square and the difference of 79 whole square and the given number, that is 79 whole square and the given number, which was 6203, 6203, which is 79 whole square is 6241 minus 6241 minus 6203. This is equal to 38. So the list number that must be added to the given number, which is 6203, is 38. Therefore, this is 38, and so and to obtain a perfect square. So the answer, there are three parts to the question. The first is, what is the least number that must be added to the given number, that is 38, and after adding the least number, the perfect square that we are getting, that perfect square is 6241, and whose square is 6241, that is 79. That is, the square root of 6241 is 79. So these are the three answers that has been asked in this question. Okay, the question number 16 is, find the least number which must be added to 8400 to obtain a perfect square. Find this perfect square and its square root. So it is same as 15. So I am not doing question number 16. Question number 16 and question number 15 are exactly the same. The given numbers are different. Okay, I am doing question number 14. I hope you can see question number 17. Okay, question number 17. Find the least number of 4 digits which is a perfect square. Also find the square root of the numbers so obtained. But find the least number of 4 digits which is a perfect square. This is another pattern of question. Now, what is find the least number of 4 digits which is a perfect square. Okay, so the least number of, okay, so least number, the idea is we have to first identify the least number of 4 digit is obviously is equal to 1 and 30. This is the least 4 digit number. Now we have to find the square root of 1000. We have to find the square root of 1000 by the long division method. So we will create periods 0, 0 and 10. Okay. So the first divisor, so the first dividend will be the leftmost period, which is 10. So the first divisor will obviously be 3. So 3 multiplied, and the question will be 3. 3 multiplied by 3 is 9, and we are having a remainder 1. And we will bring down the next period, that is 0, 0. Okay. So 100, 100 becomes the new dividend, and the next partial divisor will be the current question multiplied by 2, that is 6. That is 6. Now we have to find over here x such that find x, find largest x such that 6x multiplied by x is less than equal to 100. So this is definitely that x equals to 1. The x that will make 6x multiplied by x less than equals to 100 is definitely 1. X cannot be 2, because if there is 62 multiplied by 2 will exceed 100. So x is 1. Okay. So we got over here 61. Sorry, and we have so the 1 will get appended to the quotient, that is, it will become, quotient will become 31, and 61 multiplied by 1 is 61. 61 will get subtracted from the dividend, that which was 100. 100 minus 61 is 39. Is 39, and we have no more periods. So 39 is the remainder of the long division method. Now, so the question is, what is the least 4-digit number which is a perfect square? Now, least 4-digit number was 1000. If I subtract, so either, now the problem is we have to think what number, what is the so it is asking the least number, least four-digit number, least four-digit number. So the least four-digit, the which is a it is asking to find the least four-digit number which is a perfect square, and we know that the least four-digit number is 1000. Now, if we subtract anything from 1000, it will become three-digit number. So we cannot subtract anything from 1000. We definitely have to add something to 1000 so that to make it a perfect square. So now the question is, what is the least number that must be added to 1000 to make it a perfect square? So we can see that the current question is 31. We see that 31 square is obviously less than the number 1000 because it is leaving a remainder of 100. But and definitely this 1000 number will be less than the quotient plus 1 square, that is 32 square. So the immediately next number which will be a perfect square, but just greater than the least number which will be a perfect square and four-digit number that is a little greater than 1000 has to be 32 square. Therefore, least four-digit number which is a perfect square, which will be a perfect square, has to be equal to 32 square. 32, where did we get 32? Because 32 will be 1 plus the final quotient of the after long division method. After long division method of 1000, we get the final quotient as 31. So 31 plus 1, 32 whole square, that will be the least four-digit number which will be a perfect square. So how much is 32 square? So 32 multiplied by 32. Now if you can apply the concept of the shortcut methods of finding the square, that will be a more wise way of solving it. But I am directly multiplying 32 with 32. So this is 64 and this is 6 and 9. So 4, 12, 1024, 1024. So the least square number, the least four-digit number which is a perfect square is 1024. So what was the concept? We were asked to find the least four-digit number which is a perfect square. We know that the least four-digit number is 1000. Now from starting with the 1000, we will do a long division method. We did a long division method and we found the quotient was 31 and there was a remainder of 39. So definitely 31 square will be less than 1000. But 1000 will also be less than 32 square. That is 1 plus the quotient. 31 is the final quotient. 31 plus 1 is 32. So 1000 will be less than 32 square. So we can say clearly that the least four-digit number which will be a perfect square is some number, the least number which is greater than 1000, but which is a perfect square, and that has to be 32 square. So that so the four-digit number, least four-digit number which is a perfect square will be 32 whole square, which is 1024. Okay. Also find the square root of the numbers obtained. Okay, so the question has two parts. First it asked what will be the least four-digit number which is a perfect square, which is 1024, and it also asked what will be the square root of that perfect square, that is the least four-digit number which is a perfect square. What will be the square root of the number? Clearly that is 32. Clearly that is 32, but I will check it anyway. 32 multiplied by 32 is 1024. Okay, so these are the two parts, answers of the two parts of the question. Okay, let's do question number 18. find the greatest number of 5 digits which is a perfect square. Also find the square root of the number so obtained. So this time it is asking what is the greatest 5 digit number which is a perfect square. So the concept is we will start from the greatest 5 digit number. So greatest 5 digit number is equal to 5 nines. 5 nines is the greatest 5 digit number. So now we will do long division method of this number, that is 99959, and we can create periods 99, 99, and the leftmost period is a single digit 9. So if you do long division method, definitely the first divisor will be 9. So 3 and the quotient becomes 3. Sorry, the first divisor will be 3 and the quotient is also 3 because 3 into 3 is 9. We get 9, we get remainder 0. Okay, now we bring down the next period, that is 99. So 99 becomes the current dividend, and then the next partial divisor will be 2 multiplied by the current quotient, that is 3 multiplied by 2, 6. Now we have to see what can be x over here such that find largest x such that 6x, that is the two digit number 6 and x multiplied by x will be less than equal to 99. So this implies x cannot be 2, x can only be 1. X cannot be 2 because 62 multiplied by 2 will exceed 99. So x equals to 1. So we have 61 will be the divisor, and we have 99 dividend, and this 1 we have found x as 1. So this 1 will also get appended to with the quotient. The quotient will become 31, and we have 61 multiplied by 1 is 61, and the remainder becomes 8 and 38. And also we have another period left, that is 99. We will bring down 99, the next period 99. So now the dividend becomes 3899, and the partial divisor will be the current quotient multiplied by 2, that is 31 multiplied by 2 is 62. Again, now we have to find the x over here such that find largest x such that the 3 digit number 62x multiplied by that digit has to be less than equal to 3899. What can x be? 3899, the last digit is the rightmost digit is 9. So definitely x can be 7, or x cannot be 7 because it will exceed x. If you multiply x is 7, then 627 multiplied by 7 will exceed 3899. So it has to be 6. It has to be 6. And let's see what is 626 multiplied by 6. It is 36, 12, 15, 37. Okay, so x is 6. So we have 6 to 6, 3899. This 6 will also get appended to the current question. So the current question will become 316, and 626 multiplied by 6 is 3756. The remainder becomes 341. 143 is the remainder, definitely because there are no more periods left. So this is the remainder 143. Now, okay. Now it is asking to find the greatest 5 digit number which is a square. Now we started with the greatest 5 digit number. Now definitely we cannot add anything to the greatest 5 digit number, because if we add anything then it will become a 6 digit number. So obviously we have to subtract some number from the greatest 5 digit number, that is 99959. We have to subtract something so that it becomes a perfect square. So now the question becomes, that what least number must be subtracted from the 5 nines to give it a perfect square, and the answer is obviously 143, and the answer is 143. So therefore uh, uh, the least therefore greatest 5 digit number, 5 digit perfect number, perfect square number, or perfect square number has to be equal to 9959 minus 143. So this is how much? This is 9 9 8 9 9 8 and 5 6, and this has to be equal to the current quotient minus 1 square. No, this has to be equal to the current quotient square, the current quotient whole square. So there were three parts of the question. Find the greatest number of 5 digits which is a perfect square, which in this problem is 99856. This is the answer. And also find the square root of the number so obtained. So the greatest 5 digit number which is a perfect square is 99856, and the square root of 99856 is definitely 316. Let me quickly check if 316 multiplied by 316 is 99856. Okay, so let's do question number 19. This is a kind of what problem? So the area of a square field is given as area 60025 meter square. So area is 60025 meter square. A man cycles around its boundary at 18 km per hour. In how much time will he return to the starting point? A man cycles around its boundary. So it is a square field. The area of square field is given to be 60025 meter square. So it is a square field. So definitely all the sides are equal. So let's say x, 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 x. So area, if you assume let side of square field be x meter. Okay, let a side of the square is x meter. This will imply area of field will be equal to x multiplied by x, this much meter square. Since it is a square, we know the area of a square is side square. This is equal to x square meter square. So this implies it is given that the area of the square field is 60025. So we can say x square is equal to 60025. From here we can we need to find. It is asking that a man cycles around its boundary at 18 km per hour. How much time will he return to the starting point? This means how much time will it take for the man to cycle the entire boundary of the square? So for that we need to find the side of a square, because we need to find the entire boundary, and the boundary will be the perimeter of the square field, which will be 4 times the side. So that is the reason we have to find first the side of the square. So this implies x is equal to the square root of 60025. So let's now find the square root of 60025. I will do it quickly. I will not explain all the steps. I will just say, I hope you will understand. So the periods will be 25006. The first divisor will be 2, question will be 2 and 4, and the remainder is 2. The next period will be bring down, so 200. So the next dividend becomes 200. The next partial divisor will be the current question multiplied by 2, so which will be 2 into 2, 4. And now I have to find this x over here such that 4x multiplied by x will be less than equal to 200. So this implies, what can x be? Can x be 5? No, 45 into 5 will exceed 200. So x can only be 4. X can be 4. So x is 4, and this 4 will also get appended to the question 24, and 44 into 4 is 16176. The remainder is 24. The remainder is 24. Now I will bring the next period. And the next dividend will be 2425. 2425. Okay. And the next partial divisor will be whatever the current quotient is, which is 24 multiplied by 2, that is 48. And now I have to find x such that 48x multiplied by x will be less than equal to 2425. What can x be? Can x be 5? Can x be 5? I think x will be exactly 5. You could consider 5 because x square is 60025. So definitely 60025 has to be a perfect square. So 25, 40, 42 and 24. Okay. So over here this will be 8. This will be 5. And 5 will also get appended to the question 245, and 485 multiplied by 5 is 2425. The remainder becomes 0. There are no more periods. Therefore, x, which is the square root of 60024, square root of 60025 is equal to the current question, that is 245. So the side of the square field is 245. This implies boundary length will be equal to the perimeter of the square field, which is 4 into side, that is 4 into x. This is equal to 4 multiplied by 245 meter. Whatever that is, I will not calculate now. Therefore, time taken. Okay, so before that, speed of cycle is given to be 18 kilometer per hour. Remember that the area of the square foot is given in meter square. So the side we have found is in meter. The side of the square is 245 meter, and the boundary length is also in meter. So speed of cycle is 18 kilometer per hour. This means you have to convert the 18 kilometer into meter. So this will be 18 into 1000 meter per hour. Now, therefore, from the unit and time concept, we can say that time. So this implies the speed of the cycle is this. This implies that 18,000 meter is covered in 1 hour. So this implies the boundary of the square field is 4 into 245 this much meter is covered in from the unitary method or from the unit and time concept, you know that this will be 1 by 18,000 multiplied by 4 into 245. This much hour. This will be this much hour. Will be the time taken to for the man in bicycle to cover the entire boundary of the square field. How much is this? Now, okay. So, so it is 4 multiplied by 245 divided by 18 into 1000. Okay. Now, uh, 1000. 18, 18, 65, no, 245. So how much is 245 multiplied by 4? This is 20. 20, 16, 18, 9, 980. 245 multiplied by 4 is 20, 16, 18, 9. So this is equal to 980 divided by 18 multiplied by 1000, this much hour. So we can cancel 1 0 and can cancel 1 0. And what is 18 divided by, if we divide 98 with 18? Okay, now let's, so this is 98 pi 18 multiplied by 100. Now we can cancel with 2. This is 49 and this is 9. So let's so this will be 5. If you divide 49 by 9, it becomes 45, 4 point 436, 4. So 5.44, something like this, divided by 100 hour. Now this is equal to how many, how much, in how much time will he return to the starting point? So this is equal to, now if you, this is in hour, if you convert it into second, if we convert this into second, 100 multiplied by 1 hour is equal to 3600 seconds. So this will be 3600, this much seconds. This is equal to 100 cancels out 2 zeros. So now this becomes 544 multiplied by 36. So this will be 24, 24, 26, 32, and this is 12, 13, 16. So 4, 8, 5, 9, 1, and we have, so this is roughly 195.84 seconds, you can say, or you can say this is also equal to 0.0544 hour. I mean, this is not a good looking figure. It can be easily said this is 195.84 seconds is good, but you can also convert 195.84 seconds in minutes and seconds. Anyway, so in how much time will you return to the starting point? So the answer should be 195.84 seconds or 0.0544 hour if I have not done any calculation mistake. So this was all. so this brings to an end in solving the problems of exercise 3E. So finding the square root of a perfect square using long division method, that is so, so that's what we learned in this video. And also, if a given number is not a perfect square, using the long division method, how do we find the least number that must be added to the given number to make it a perfect square, and what must be the least number that must be subtracted from the given number to make it a perfect square. Also, we have solved a problem where it is asking to find the least number of 4 digits or some number of digits which is a perfect square, and also the greatest number of 5 digits, or it could also be 4 digits or 6 digits to which will be a perfect square. So I hope you understood the concept of long division method, how to find the square root of a perfect square, and applying that concept, long division method, how do we solve some very typical pattern of question, that is the least number to be added or subtracted to a given number to make it a perfect square, and the least number of 4 digits or 5 digits or 6 digits which is a perfect square, and the greatest number of some number of digits, that is greatest number of 4 digits or 5 digits or even 6 digits which is a perfect square. So I hope this video was beneficial to you. If it is so, then please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So I have no notes, quick notes for this video, as I thought it was very difficult for me to prepare a notes of how about the long division method. I thought directly solving the problem will give you a better insight, a better understanding of how it works. So I thought of directly solving the problem. Okay. So the next topic is about finding the square root of the decimal and fractions, which I will continue in the next video. So thanks for watching, and until the next video, take care and bye.